Hello dear students. So in vectors chapter we have to cover all these topics, and from this list we have already covered the terminology and the notation, and today we are going to talk about vector addition. So without wasting any further time, let's start everyone. And yep, let me just select the pen and let's start. If you haven't subscribed the channel, the Vedantu Science Olympiad channel yet, please do that. Okay, and we'll bring you great academic videos to help you learn science in a better manner. So do subscribe to the channel, everyone. Let's begin now. So today we are going to talk about vector addition. All right. So what is that we are seeking? We are trying to learn that when we add two vectors, let's say two vectors have been given to us. Okay, for example, A and B vector, they are given to us, and we want to find out the vector that we will get when we add these two vectors. Okay, something like this. Okay, like let's say we have a vector A here. Okay, let's call this as vector A, and let's say this is another vector B. Okay, and we want to know that when we add these two vectors, what is the outcome? Now students, when I say what is the outcome, you must think about this, that when we add these two vectors, the outcome, are we expecting it to be a scalar quantity or are we expecting it to be a vector quantity? So let me tell you this, that when we add two vectors, okay, we end up getting a vector quantity. And let me also add that if you are trying to add two vector quantities, then these two vector quantities, they need to have the same dimensions. Okay, what does that mean? I'm not sure whether you have covered dimensions chapter as of now or not. So what I'm trying to say is that you cannot add force vector to, let's say, velocity vector. You can't say that I have a force vector and I want to add it to a velocity vector. This is something that you can't do. You can add a force vector to another force vector. You can add a velocity vector to another velocity vector. Okay, you can add a momentum vector to a momentum vector, but you can't add a momentum vector to a velocity vector. So the two vectors that you are trying to add, they must belong to the same, they must be of the same physical quantity. Okay, if that is the case, then we can add the two vectors. Right now we are assuming that the vectors with which we are dealing, vector A and vector B, they are of the same same quantity, let's say force. Okay, so what is, let me reiterate, what is that we are trying to seek, or what is that we are seeking? We want to know that when we add these two vectors, the result that we will get will that be a vector or a scalar? The answer to this question is it will be a vector. Now that I know that I'm going to get a vector output, I'm going to get a vector result, I must ask myself how long that vector will be and in which direction will that vector point. In other words, I need to identify the arrow. I need to identify the arrow that can represent the resultant vector. So the question is, how do I identify that arrow? How do I discover the arrow? If I add these two arrows, what is the arrow that I'm going to get? Where will it be? Where will its tail lie and where will its head lie? The answer to this question can be found by a simple observation related to displacement. So I'll tell you what the premise here is. What is the assumption that we are making, students? We are assuming that the way to add all vector quantity is same. In other words, in whatever manner I'm going to add displacements, the same method, the same manner will apply to add forces or to add momentums or to any other vector. Okay, so why we are talking about displacement? Because it is quite intuitive and easy to understand. For example, we have discussed this example before. Let's say a person walks 5 kilometers in one direction and then 5 kilometers in another direction. So these would be two different displacements. Okay, we can label them as, let's say S1 vector. Okay, we generally use S for displacement. So this was the first displacement, S1, and we can represent this as the S2 displacement. So we have two vectors, S1 and S2. And in this figure, if I tell you that, can you give me the total displacement of the particle or of the person, then from the concept of displacement, you know that displacement is a straight line or straight arrow starting from initial position and drawn towards the final position. So the person started from here. Currently the person is standing here. So the direct arrow is this one. So this has got to be the resultant vector. So when we draw this figure, or when we recognize that what is happening here, let me tell you, let me put it in words what is happening here. So we had two vectors to add, and we noticed that if we make a figure, if we draw a figure in which the tail of one vector lies on the tail of another. All right, we are trying to add two vectors. If we arrange them in a manner such that the tail of one vector lies on the tail of lies on the head of another vector, like so head and tail, like they are the male and the female points of the socket. So one tail will occupy one head, let's say. So you have to arrange the vector in a manner such that the tail of one vector, any one vector, lies on the head of the other. Okay, so this pair is made. Then what we have to do, we have to join the free tail. This tail did not have any head at it. Okay, so join the free tail with the free head, and in doing this, in doing so, the arrow that you are going to draw, that arrow represents the resultant vector. So we have now discovered, may not be the right word, recognized should be the the applicable word here. We have recognized how to draw the resultant vector. All right, I'll summarize this also. Okay, I'll summarize this also. We have been given two vectors. We have studied about the property of invariance. Invariance allows us to shift the vector at our will. We just have to ensure that we are not changing the orientation of the vector. We are maintaining the orientation of the vector. Okay, so we can shift these vectors, any of these vectors, maybe both of these vectors, so that we can put the tail of any one vector over the head of the other vector. Once we have done that, whichever free tail we see, we have to join that free tail to the free head, and this arrow is our resultant vector. So the steps are defined here. It says arrange the given vectors in a manner such that the head of one vector lie at the tail of the other. So if I shift b vector simply here, okay, if I simply shift b vector here, okay, then I would have put the tail of b on the head of a. Okay, or else what I can do, I can maybe shift a vector here. Um, uh, I can bring this tail here, okay, and this head here somewhere like this. If I do that, I would have put the head of b on the tail of a. Okay, so this has been depicted in the next diagram. So here we are shifting b so that the tail of b is on the head of a. Here I have shifted a so that the tail of a is on the head of b. In both cases, if I draw arrow to join the free tail with the free head, okay, something like this, um, something like this. Okay, in both the cases, if I join the free tail with the free head, then you don't have to do both. You don't have to do this and this. I'm saying this or this. Do any one. In both cases, you will get identical arrow. I hope you can realize that the two arrows that I have drawn, they are parallel to each other. They are of the same length, so they are equal. So either you do this or you do that. You don't have to do both. So once we do that, we get the resultant vector. We identify the resultant vector. So the steps are: join the free tail with the free head by drawing a straight line. The free tail will become the tail of our vector, and the free head will become the head of our vector. Free here refers to unoccupied. So I hope this much part is clear to everyone. So when we do that, we get these vectors as the R vector. So till now, what we have learned? Till now, we have learned to identify. We are yet to calculate the magnitude of the resultant. We are yet to talk about the direction of the resultant, but we have learned to recognize the resultant vector. मैं पहचानूंगा रिजल्टेंट को, तभी तो मैं उसकी लेंथ और डायरेक्शन निकालूंगा. सो ओनली आफ्टर आई recognize the resultant vector, I can then talk about the length and the magnitude and direction. So the first step is done. Okay, further steps are left. Let us practice a few things before we proceed further. So here you see a hexagon. It's a regular hexagon. Okay, and all the vertices of the hexagon, we have named them as A, B, C, D, E, and F. All right, it's a regular hexagon. So in a regular hexagon, all the sides are equal. Okay, and now what we have done, we have named AB vector. So there is this is another way to name a vector. Like you can name a vector like this. Okay, if you write A, B, you write the alphabets A and B, then you put an arrow overhead. All right, so the tail is above A, the head is above B. So AB vector will represent a vector moving from A to B. Okay, and AB vector has been represented by P vector here. So we have named the AB vector as P vector. So this is another way of naming a vector. Okay. Similarly, we have named BC vector as Q vector, and now we want to write these vectors using these two vectors, using P and Q vector. So we want to write AD vector. Okay, we want to write AD vector. So you would love this question, guys. Watch this, how we are going to do this. To do this, what you must first know is the property of regular hexagon. So let's first talk about some property of regular hexagon, because the question is using that. Okay, so some of the like whatever I'm going to tell you, you'll probably okay, whatever I'm going to tell you, you will agree with me. It's simple only. So a regular hexagon looks somewhat like this, all sides being equal. This is the center. If I join the center with all the vertex, do you agree with me that we get 6 equilateral triangles? We get 6 equilateral triangle, which means all the lines that you see here, they are of same length. Okay, they are of same length. And not only that, this angle, this angle, this angle, all these angles are 60 degree. Okay, so what I can conclude here is that if I name this point as A, this as B, this as C, this as D, this as E, this as F, and the midpoint, let's say O. Okay, then let's talk about AO vector. Is AO vector the same length as vector P as well as vector Q? Yes, lengthwise it is same, but the direction of AO matches with the direction of BC. In other words, I can very well say that AO vector is same as BC vector, which is same as Q vector. Please check whether you agree with me or not. AO vector has got the same length as BC vector, and it has also got the same direction. So AO should be same as BC. And not only that, if I talk about OD vector also, okay, if I talk about OD vector also, then OD vector is also same as BC vector. Okay, it is also same as BC vector, same length, same direction. Okay, in other words, if I'm trying to write AD vector, okay, AD vector, can I say that this is a vector which is parallel to, okay, I was not able to draw a straight line, let me erase this. Okay, so if I say that AD vector, okay, AD vector is a vector parallel to BC vector and double of its length, so that means it is 2Q, or you can simply see that AD can be written as AO plus OD, and both are Q, so 2Q is the answer. So AD vector we have found, AD vector we have found, AD is same as 2Q. Likewise, we can talk about CE vector. Now CE vector looks a little bit complicated. CD vector definitely looks a little bit complicated. Let's try to see what we can do with the CD vector. Okay, so CD vector, notice guys, sorry, CE vector, right? So CE vector is this vector, and can I write this vector as CE? All right, so maybe I can write CE as, what do you think, guys? CD plus DE. Huh? You can choose any path, guys. You can choose any path. I'm just trying to choose the one which is very easy to understand. So CD, and then DE. Okay. CE can be written as CD plus DE. Okay, let's do it on the next page. Okay, so we are writing CE vector as CD vector plus DE vector. Now let's pay attention. DE vector is this vector. Can we say that DE is exactly opposite to P vector? Can we say that? Let me use a different colored pen. That would be easier for you. So can I say that DE vector is exactly opposite of P? All right. In other words, DE is same as minus P. Okay. So DE vector, my job is done. Okay. DE is same as minus P. Now CD vector. How do I get CD vector? Okay. So watch this. To get CD vector, what we can do is this. I can write CD vector as CA vector and then AD vector. Watch this. Okay, so CD can be split into CA vector plus AD vector. Okay, and DE is same as minus P. DE is same as minus P. Okay, now CA vector is opposite of AC vector. It is minus AC vector. I think that's pretty obvious. If you interchange head and tail, a minus will come into picture. Okay. Okay. So I think we are done now. I think we are done now. Why? Notice minus of AC vector. Now AC vector is P plus Q. Okay. AC vector is P vector plus Q vector. Okay. So AC vector is P plus Q. Okay. Then AD vector. Okay. AD vector we just wrote as 2q in the previous part, then minus p. So if you check it, how much is it? It is 3q, no, 2q minus q is q vector. Okay, q vector, and then we have minus 2p, q minus 2p. Okay, so that would give us that would give us CE vector. Okay, CE vector. And once I've got this, I can interpret also. So minus 2p vector would be this vector. See, I think it's easier now. This is minus 2p vector because it is parallel to p. It is double in magnitude. It is opposite to p, actually anti-parallel. So this is minus 2p and then this is q. Okay, so we can clearly see that minus 2p and q vector will give us CE vector. So this is indeed correct. Okay, getting this, everyone? Likewise, we can talk about AC vector. We have actually already taken care of AC vector. AC vector is nothing but P plus Q. So this is quite simple. We have already made use of this. And then BE vector. Okay, BE vector. So guys, if you are trying to write BE vector now, I think it's pretty simple. You will write BC vector plus CE vector. CE vector is already there. So if you are trying to write BE vector, you will write BC vector, that is Q vector, plus CE vector. CE vector is here. So this is Q plus this. So it will become 2 times of Q vector minus 2 times of P vector. So that would be your answer for BE vector. So like this we have to. So by doing this example, if you have understood this example, guys, you have understood the essence of finding the resultant. Like if we have two vectors, then which vector will serve as the resultant of those two. So practice this example, guys. Okay. So we have now learned the rules to identify R. Okay. There is also a checkpoint I would like to do with you guys. So let me give you an example. Okay. Let me try an example with you. Okay. So the example is somewhat like this. Okay. Let's say I show a diagram. Let's say this is a vector v1. Okay. And let's say this is another vector v2. Okay, and then let's say this is, notice the arrows, this is another vector v3. Okay, now I'm writing three relationships. You tell me which one is correct. Is v1 plus v2 is equals to v3? All right, or is v1 plus v3 is equals to v2, or v2 plus v3 is equals to v1? What do you think? Or maybe none. Okay, none of this is correct. What do you think, everyone? Okay, now those of you, you can pause the video and you can try. Those of you who went with this option, if you went with this option, everyone, then it is, you are wrong then. Okay, you are wrong. Generally students, particularly students who have just begun this topic, they tend to conclude that the longest line will be the resultant vector. And so if you have marked this, you are most probably thinking like this, that the longest line has to be the resultant vector, which is not the case, guys. You need to pay attention to the direction of the arrows. You need to pay the attention. Notice that v3 vector has its tail coinciding with tail of another vector and its head coinciding with the head of another vector. All right, the tail of v2 lies on the tail of v1, and then we have connected the tail, this free tail with the free head. So v3 is the resultant one, guys. Okay, let me go take you back to that figure. Notice that the resultant vector, for resultant vector, okay, the tail coincides with tail of another and the head coincides with the head of another. Okay, so in this diagram, v3 was the resultant. Okay, so this option was correct. v3 was the resultant. Getting it, everyone? Okay, let me give you one more example. Okay, let me give you one more example. We'll come to this point, but before that, let me give you another example. What if we have a situation like this? This vector and let's say this vector, and let's say this vector. Okay, this is v1 vector, this is v2 vector, and this is v3 vector. So if I now again give you options, okay, one option is that v1 vector plus v2 vector is equals to v3 vector, or if I give you the option that v1 vector plus v3 vector is equals to v2 vector, or if I give you example that v2 vector, okay, v2 vector plus v3 vector is equals to v1 vector, okay, or if I give you none of these, okay, which one will you go with? So here you see that none of the vector has the property that its tail coincides with tail of another, or its head coincides with the head of another. In this case, what is happening is, let's say you reverse any vector, for you choose any vector and reverse. Let's say I'm reversing v2. So if I reverse v2, it becomes minus v2, and now I see that for the yellow vector, the tail of yellow vector coincides with tail of another, that is v3, and the head of yellow vector coincides with the head of v1. So minus v2 becomes the resultant of the other two. So v1 vector plus v3 vector is minus v2 vector, or in other words, v1 plus v3 plus v2 has become 0. Okay, so that is the applicable relationship right now. Okay, so you could have done this with any vector. So right now in this diagram, okay, like in the red diagram, in the red arrows, none of the arrow was the resultant of the other two. Rather, reverse of any red arrow would become the resultant of the other two. Okay, now assuming that you have understood all this, okay, let's now talk about that. Once we have learned to identify the r vector, then how do we know the length of it and how do we know the direction of it? So there are two methods to it. One is the graphical method and the other is the analytical method. Now the graphical method involves usage of graph paper and scale, and a protector, the device that you use to measure the angles. Okay, and it involves drawing accurate figures. Okay, so you draw the arrows with proper measurement, in making proper angles with each other, then you draw the resultant, and then you can measure the length of the resultant arrow, and then you can use scale to get the resultant magnitude. So this is pretty long. Okay, it is not a viable method from examination point of view. Okay, we need something by which we can calculate and get the answer. So graphical method involves the usage of graph paper, a lot of properly drawn figures. It's very time consuming, so we'll not spend time on this. We'll spend time on the analytical method. So to use analytical method, I would ask you guys to recall the cosine law, the cosine formula that we learned in basic mathematics in one of the previous sessions. So we learned that for any triangle, okay, let's say if we name the triangle as ABC, okay, then the side opposite to A becomes small a, the side opposite to C becomes small c, and the side opposite to B becomes small b. And if there is any angle, let's say we are talking about cos of A, okay, cos of this angle, cos of angle A, then we write it as b square plus c square minus a square upon 2bc. All right, and if we rearrange it, we get a square is equals to b square plus c square minus 2bc cos of angle A. So we are going to make use of this formula. Why? See, this formula tells us the length of, like, the length of one side of a triangle in terms of the length, other two length, and the angle between them. The angle A is the angle between B and C. Okay, so we are going to make use of this formula. Let's pick up the same example that we took for displacement. So let's say this angle is 120 degree. Let's say this angle is 120 degree, and we know that this length is 20 and this length is 30, and we want to find out the length of r, the length of this side of the triangle. What do we do? It's simple actually. We put in this formula. Okay, we put in this formula, 20 square plus 30 square minus 2 times 30, 20 is cos of 120. We put in this formula and we will get the answer. Now, one point to keep in mind is that we learnt that when we talk about angle between two vectors, we need to make the vectors either co-initial or coterminous. That is the different arrangement. When we are trying to identify the resultant, we put the tail of the one vector on the head of the other. When we are trying to identify the angle between the two vectors, we make them co-initial or coterminous. In this diagram, 120 is not the angle between these two vectors. Let's say this vector is a vector, suppose, Okay, suppose this vector is A vector and this vector is B vector. Okay, so 120 degree, okay, let me put B here. So 120 degree is not the angle between A and B, rather this angle, this angle is the angle between A and B. Okay, this angle is the angle between A and B. So if I want to change this formula in terms of the angle between the vectors, so instead of minus cos A, I would probably write uh, plus. I would change it to plus. Okay, plus, and cos A will change to cos of pi, or 180 degree minus A, which is same as theta. 180 minus 120 is same as theta. So the formula that we will get is this. Okay, you are trying to find out, like, let's say if this vector is A vector, if this vector is B vector, and if this length is the resultant. Okay, if this is the resultant, angle between the two vector would be this, and the length of resultant vector will be obtained using root of A square plus B square plus 2AB cos theta. Theta is this angle, it is the angle between the vectors. Okay, so you have to learn this formula, everyone. Okay, you have to learn this formula, and then we'll be using it as and when needed. Okay, let's try an example on the same. Okay, let's try an example. So uh, we'll do the example, but before we do the example, there's one thing to understand. If I give you the liberty to change theta, okay, if I don't change the length of A and B vector, but if I allow you to rotate B vector in whichever way you want it, if I allow you to change the direction between two vectors, the angle between the two vectors, what value of theta will give me the maximum magnitude of r? Can you realize that if we put theta as 0, that means if we make these two arrows in the same direction, okay, then we get the maximum length of the r vector, which is quite evident from the figure also. Like in this case, r vector would be maximum in length. Okay, are you getting it? If I put theta as 0, so that means if the two vectors are in the same direction, then we get the magnitude of resultant as maximum. We are keeping the length of the vector same, we are only modifying the angle between them. So what to do to get the maximum resultant or maximum magnitude of the resultant? You draw the arrows in the same direction. Okay, on the other hand, if these two were opposite to each other, if these two vectors were opposite to each other, in that case the resultant would have been minimum. Okay, in that case the resultant, so it's written two vectors of fixed magnitude give minimum magnitude when their direction is exactly opposite. Okay, getting it, everyone? And now these two things can be deduced even from the properties of triangle, so in a triangle, okay, in a triangle we know that uh, the third side, okay, the third side is always smaller than the sum of these two. All right, or at least it can at most become equal to the length of these two. Okay, so the resultant, the maximum value of resultant can be equal to this plus this, and that happens when they are in a straight line. The minimum length that this side can has is the difference of these two, and that will happen when they are exactly opposite to each other. So from triangular inequalities also, point number 1 and point number 2 can be reduced. Point number 3, okay, it is the same, like the magnitude of the resultant vector, that means magnitude of r will always be less than or equal to magnitude of a vector plus magnitude of b vector. Okay, similarly magnitude of r will always be greater than equal to magnitude of a vector minus magnitude of b vector. Okay, all right, getting this, everyone? Okay, I think I have turned on the captions. Yeah, okay. So here is a question between for us. Two vectors 2 and 3 have resultant of magnitude 7. Find the angle between them. Let's try it out. So what we are saying is that r is equals to root of a square plus b square plus 2ab cos theta. Now r is root 7 is equals to a square. So 2 square is 4, 3 square is 9. 2 times of 2 into 3 into cos theta is what we are getting. Let's take squares on both sides. So we will get 7 is equals to 4 plus 9 is 13. So 13 plus 12 cos theta. So from here we will get cos theta as 7 minus 13 is minus 6 by 12. Okay, minus 6 by 12 is minus half, which means theta is, cos theta is minus half for 120 degree. So theta is 120 degrees. So now I can even think about the the kind of figure that we would be getting. So one vector is like this, the other vector is somewhat like this. Okay, somewhat like this maybe. Okay, like this angle is 120 degree. Okay, this angle is 120 degree, and therefore the resultant is somewhat like this. Okay, this is the kind of situation we can anticipate in this case. Okay, so we have found out the formula to find the length of the resultant. Okay, now what remains is that we know that resultant is of this length, of whatever length, root 7. What about the angle that the resultant makes with any one vector? Like, do we know that angle? We need to find a way to know that angle also. So if this is vector A, this is vector B, theta is the angle between the two vectors. If the resultant makes angle alpha with R, okay, then this is the formula that we are going to use. Tan alpha will be equal to B sin theta divided by A plus B cos theta. All right, it's actually a very simple formula to derive. I will show you. So let's say if I drop a perpendicular from here, if I drop a perpendicular from here like this, okay, and if I call it as, let's say, H, okay, and let's call this length as anything, let it be L, okay, then notice that cos theta, okay, cos theta is base upon hypotenuse. So this is base, this is hypotenuse. Okay, so we have written cos theta. Similarly, sin theta will be H upon B. Okay, in other words, if I want to get L, it would be B cos theta. If I want to get H, it would be B sin theta. Okay, and then notice that if I'm trying to write tan alpha, okay, if I'm trying to write tan alpha using this entire triangle, then perpendicular is H and base is A plus L. Base would be A plus L. So H will become how much? It is B sin theta. Okay, B sin theta, and then A plus L. L is how much? It is B cos theta. So notice that this is the same formula that is written here. Okay, so tan alpha is B sin theta. So if alpha is the angle with A vector, then A will come here and the other vector will come here. If beta is the angle with B vector, then B will come here in the denominator only once and the other vector A will come here. Otherwise, these two formulas are same. You can notice in these two formulas only A and B are getting interchanged. Okay, so R vector, what makes whatever angle with whichever vector, if it's made with A vector, A will appear only once in the denominator, and it will not be with any of the angles. The other vector will appear with the angles like B sin theta, B cos theta, and so on. So that way you can remember the formula. Okay, so again, these are the formulas that you need to learn and we are going to use them. Please learn them. Okay, so we have done this question. Okay, we have done this question. Now, difference of two vectors. So we have talked about the sum of two vectors. What about difference of two vectors? So let's say we have been given two vectors, A vector and B vector, and we have been asked to calculate the difference of these two, vector A minus vector B. Now this is something which is same as addition. We just need to have the right interpretation. Watch this. If D is A minus B, I can write D as A plus of minus B. I can write D as A of plus A plus minus B. Now what is minus B? Minus B is a vector which is exactly opposite to B and having the same length as B. Okay, exactly opposite to B and having the same length. So if I add A vector and minus B vector, I get the difference of A and B. So I just need to add these two vector, and to add these two vector, what do I need to do? I need to shift the vector so that its head coincides, its tail coincides with the head of the one. So I need to draw A vector something like this. So this is A vector. Getting it? This is, I've tried to create a copy of it, and now if I join the free tail with the free head, okay, so this is actually the sum of these two. This vector is A vector plus minus B vector. So it's actually A minus B vector. That is the difference vector. Okay, getting it, everyone? All right. So that's it. Now this is the copy of B. Okay, now you have to notice this, that if theta is the angle between vector B and vector A, if theta is the angle between vector B and vector A, then angle between A vector and minus B vector, minus B will be opposite, that would become 180 minus theta. Okay, so if theta is the angle between A and B, then the angle between A and minus B will be 180 minus theta, and we have to find out the sum of these two. So we will substitute 180 minus theta in the formula of resultant. So a square plus b square plus 2ab cos of 180 minus theta, cos of 180 minus theta. So this is the formula to get the length of the difference of the two vectors. So and again the same thing will happen here when you are trying to find tan alpha, use 180 minus theta, same thing guys. Okay, so summary is this, if we are trying to add two vectors and they have angle theta between them, then the magnitude of resultant will be given by this formula, whereas the magnitude of difference will be given by this formula. The angle that r vector makes with a vector will be given by this formula, and the angle that d vector makes with a vector will be given by this formula. What is the difference between these two? Only the plus and minus have been interchanged. Here also the same difference, only the plus and minus have been interchanged. Okay, and that's it. So this is something that you need to remember. All right, this is something that you need to remember. It will help you solve all kinds of questions. Okay guys, I will share an assignment also on the same in the description of this video. You try to solve that assignment and things will become better to you. Okay, now let's talk about the parallelogram and the polygon law. Now what is the parallelogram law? So let's say we have two vectors a and b, and I created copies of both the vectors. I created one copy of a, I created one copy of b. Now I have four sides, as you can see, and think about this guys. Can I use these four sides to create a parallelogram? What do you think guys? Will I be able to create a parallelogram using these four sides? So I most certainly I will be able to do it, and this is how the parallelogram will look like. You notice that this is a vector, this is a vector, same length, same direction, so both are same. B vector, same length, same direction, so both are same. Now notice something very, very interesting. Okay, if I draw an arrow like this, and I've put the arrowhead here, this arrow, can I call this arrow as sum of b and a? Okay, so this arrow is resultant. Okay, so resultant vector, okay, r vector we have got. So that is one of the diagonals. This is one of the diagonals. Okay, now let's say if I, instead of drawing the arrow here, if I put arrow here on this vector, okay, so this is now minus b vector. This is now minus b. Okay, this is now minus b, and notice that the minus b, ignore r vector now, ignore the existence of r vector now. Minus b vector's tail is on the head of a vector. Okay, so what we are saying is this, that a vector plus minus b vector is the other diagonal. The other diagonal is, okay, this diagonal is a vector minus b vector. So what I'm trying to say is that in when we construct a parallelogram using copies of vectors, you know, two vectors were given to me, I created copies of them. So one of the diagonal will represent the sum of those two vectors, and the other diagonal will represent the difference of those two vectors. So very useful result everyone, so please learn this. So here I've turned this the lower one into minus b. Okay, and then we are getting, see, the blue one, okay, that is the sum of the two vector, and the green one, that is the difference of a and b. All right, okay, so parallelogram law states that when we use two vectors to represent adjacent sides of a parallelogram, the two diagonal represent sum and difference of the two vectors. Remember this everyone, and using this we can actually draw very, very important conclusions too. Okay, what kind of conclusions? So see, if these are the two sides of a parallelogram, okay, the parallelogram is not completed here. Let's say if we complete the parallelogram by drawing like this and like this, and if we complete it, okay, let's say, so the diagonal, the sum of a and b will lie in this range only. So the resultant vector will lie in between the two vectors, in between the, and this is something that you can realize by in practice also. So let's say there is a block, somebody is trying to pull the block here, someone is trying to pull the block here. Can you imagine that the block will probably move in this direction, or in this direction, or in this direction, or in this direction, somewhere in this region? If two persons are pulling like this, it cannot go like this or in that direction. It will goes somewhere between the two arrows. So that is what we are trying to say, that if there are two vectors which are getting added up, the resultant will lie between them. Okay, so that is one. Secondly, if magnitude of A and magnitude of B are equal, then the vectors will have equal magnitude and the parallelogram will change into a rhombus now. Okay, and the rhombus has a property that the diagonal is equally inclined to the two sides. So in a rhombus, okay, in a rhombus, okay, both the diagonals, okay, so this diagonal will be equally inclined and this diagonal will also be equally inclined. So the resultant will happen exactly midway between the two vectors. So if there are the vectors are the vectors which we are trying to add, if they are equal in magnitude, then the resultant lies exactly midway between the two vectors. So the resultant makes theta by 2 angle with both the vectors. Okay, so now whenever they are not equal, the vectors will have unequal magnitude and the resultant will be tilted towards the vector of larger magnitude. So you can see here that if magnitude of A is equal to magnitude of B, then alpha is equal to beta. Alpha is the angle that resultant makes with A vector and beta is the angle that the resultant makes with B vector. If magnitude of A becomes more than magnitude of B, then this is wrong here. Okay, alpha will become smaller than beta. Okay, and alpha will become greater than beta. So whichever vector is larger, okay, the resultant tilts towards that vector. So if B is larger, the resultant will be closer to vector B and therefore beta angle would be smaller than alpha angle. Okay, so these are the results that you can remember. And now polygon law, it's an extension of triangle law. Let's see. So suppose I've been given 5 vectors and I've been asked to get the resultant of these 5. Like if I add these 5 vectors, where will I get, where will the tail lie, where will the head lie? We want to know that. So how do we do that? How do we do? Okay, so this law says that you need to arrange the vectors in a manner such that the head of one lies at the tail of next. Order doesn't important, order doesn't matter. You see this, we have arranged the vectors in a manner such that the head of one lies to the at the tail of the next. Okay, and then you join the free tail with the free head, that will give you the resultant vector. Okay, in case this head automatically ends at the tail of the first one, it would mean that the resultant is 0. Okay, so that's how we find out the resultant. And again, order will not matter. I'll try to do this for you guys. I'll try to do this. So let's say vector A is in this direction, vector B, okay, instead of vector B, let me do with vector C. So vector C is somewhere here, this is vector B. Now I'll draw vector B somewhere here. Okay, now vector D maybe somewhere here. Okay, and now vector E maybe somewhere here. And now if you draw resultant, okay, you see that it would be similar to what, of course, I've drawn, I've done freehand drawing, so it will not match perfectly, but yeah, if you actually draw properly with measurements, you will get the same arrow as what you would get with another order. Okay, so on that note, guys, I will end today's session. I hope that you guys have subscribed to the channel. If not, subscribe it soon. Guys, this is a math course that we are doing to learn physics, like the essential maths that we need to understand physics. We are covering here that. You might find this a bit tough for you, but take my word for it. If you stick to the course, if you watch the sections of the video which you are not able to understand repeatedly, if you try the questions that I'm sharing in the description of this video, then you will be able to grasp the ideas that we will need to understand physics in a better manner. All right, even if you're not able to understand each and everything whatever I've taught here, stick to it, guys. Try to repeat the video once more. Okay, you have to learn a few things. Once you've done that, you will become good enough to understand any concept in physics that we are going to teach you. On that note, guys, I will end today's session. I hope you had fun. I hope you enjoyed the session. Take care, everyone. Bye bye.